So today we will be considering Mealy and Murray machine. Now, first I'll be considering the construction and then we will be considering the conversion. Fine. If we talk about Mealy and Murray machines, the most important characteristics of these machines are that they are machines with output. That means corresponding to every input, there is output at every state. They are compulsorily DFAs. We don't have NFA as a Mealy or a Murray machine. And since we get output at every state, corresponding to every input, there is no final state in Mealy and Murray machine. Now just consider this machine. This is an example of a two-state Mealy machine. In Mealy machine, we get output at every transition. If we see this particular transition diagram for Mealy machine, if we move from Q0 to Q1, on input A, the output is 1. If the input is B, output is 0. Likewise, in state Q1, if input is A, output is 0, and if input is B, again here output is 0. This is how we give the diagrammatic representation of Mealy machine. In Murray machine, the output is available at every state. Just see this particular example. In this case, if we move from Q0 to Q1 and input is A, the output is depicted here. That is, when we reach Q1, the output is 1. If I am at Q0 state and I have an input B, the output will be 0, because if there is a transition from Q0 to Q0 on B, we will move to Q2, and when we move to Q2, the output which we will get is corresponding to where we reached. So output will be 0. Likewise, if in state Q2, if we have an input as A, then output which will be generated is 0. Now, normally there is a minor confusion between Mealy and Murray machine. So in order to overcome that, one can say that we can differentiate these two machines by recalling that the machine with double O, that is Murray, has output in O, that is in the state. Now we come to drawing of Mealy and Murray machines. We have discussed the characteristics and how we go around with Mealy and Murray machine. Now say for example, we want to draw a Mealy machine for 1's complement. 1's complement means that every 1 will be 0 and every 0 will be 1. So this is a simple Mealy machine for 1's complement. Corresponding to every input which is 1, the output will be 0, and corresponding to every 0 input, the output will be 1. Now say for example, we will see step by step. Say for example, I have an input 1, 0, 1, 1. What should be the output? It should be 0, 1, 0, 0. Because we are taking into consideration machine for 1's complement. Now when I give 1 as input, what will happen? This particular state will be ignited. The output which I will generate will be 0 corresponding to first 1. Now I move to second input, which is 0. If I have input as 0, so this particular transition will take place, and what will be the output which will be generated? That is 1. Likewise, I have third character, which is 1. Transition will take place corresponding to 1. Output will be generated as 0, and final transition will take place in the similar manner. Input will be 1 and output which will be generated is 0. So this is how we draw a Mealy machine for 1's complement, and the trace we have given for 4 input string. Now if I talk about Murray machine for the same, that is for 1's complement. Again, 1's complement has been defined. What is 1 complement? If input is 1, 0, 1, 1, output should be 0, 1, 0, 0. So this is the Murray machine. Just see, if I have input 0 at Q0 state, output should be 1. If I have input 1, output should be 0. Now, at this point, if I get 0, what should be the output? Output should be 1. So I have drawn a circle around it. Whenever a 0 comes, output is 1. If I am at Q1 state and a 1 comes, output should be 0. If I am at Q2 state and a 0 comes, output should move to 1. So based upon the output which we want, we have drawn this machine. Now let's take a trace for 1011. Initially, I am at Q0 state. Now the moment I get 1, the transition will be from Q0 to Q2, and the output which will be generated is the one which is based upon Q2. So the output will be 0. Now next input is 0. I am on Q2 state and I will move on 0 to Q1 state. So what will be the output which will be generated if I move from Q2 to 0? Output will be 1. Now I move to third character. I was presently at Q1 state. I get a 1. I move to Q2 state on getting a 1, and output which will be generated is 0. Likewise, when I am in Q2 state corresponding to 1, I'll move within Q2 with a cycle of 1 and the output will be 0. Now we want to draw a second question is, we want to draw a Moore machine which counts number of occurrences of 110 in a string. So what are the intuitions behind the design of this machine? Basically, we want that machine should give 1 only when 110 string is accessed in the input. Just take an example. If we have a machine with input 11, 110, 110, 1010, output should be all zeros except 2, 1, because when 110 is encountered, this is what we want as the output. It should be 1. Next 110 is encountered, it should be 1. So number of 1 indicate how many times string 110 occurred in our machine. Now we have also the designing constraint that machine should be compulsorily DFA. So let's start with the designing. Initially, step 1 will be that we'll draw a machine with 4 states. Why 4 states? Because we have input of 3, 1, 1, 0. So output at the end of 110 is 1 and all other states will have output as 0. So just see this. This is the first diagram which will have corresponding to counting of number of occurrences of 110. For all 1, here the output is 0. In the second state, output is 0. In the third state, output is 0. But here output is 1 because we have 1, 1, 0, which we actually want. Now we will start with completion of DFA. Corresponding to Q0 state, just see, we already have Q0 1, that is Q1. So we need to draw Q0 0. Now, since 0 at initial state won't make any difference, n number of zeros you have, so you can have a loop at this point for Q0 0. Then we move to next state, that is Q1. Q1 corresponding to this state, in Q1 we already have Q0, Q1 transition of 1 is Q2. This state is already there. We just need to find out what should be the output when Q1 0 is there. Since 1 followed by 0 will not make any sense, what we will do is we will make a move from Q1 on 0 at Q0. Now we move to Q2. So we have completed first 2 states of DFA. We move to Q2. In Q2 corresponding to 0, we already have a state, that is Q3. Now we want to know what should be Q2, 1. If we get a 1 at this point, we can always iterate it because we will get 110 whenever we keep on iterating, because we want to count the number of occurrences of 1. Now the last state is left out. We have already completed the DFA for Q0, Q1 and Q2. Now we want to complete the DFA for Q3. We see that there is neither a move corresponding to 0 nor corresponding to 1. So first we will try to find, if it is a 0, that means we have already encountered 110. So we should move back and start the checking altogether from Q0 state in order to find that whether there is any 110 or not. If I have 1 at this particular point, what I will do is that I will take into consideration this one as one of the inputs for 110, and I'll move to Q1 since I've already covered 1, 1, 1, 0. So my occurrence will be 1. So this is how I draw the Murray machine for counting the number of occurrences of 110. Same pattern, exactly the same pattern will be followed for Mealy machine. Initially, we will draw the machine with all inputs as 0, 0. When 1 will be encountered, when we will get 1, 1, 0. Now we will check that this is a DFA. In order to check this, corresponding to Q0, on 1 we have a transition, on 0, since n number of zeros at the starting hardly make any difference, we should put this at a loop on Q0 itself. We move towards Q1. There is already a transition from Q1 on 1 to Q2. So we need to find what will be the output, where we should move the output when we have 0. Now we should move this back because it doesn't make sense if we have 0 after a 1. Next, when we have completed this, we will move towards Q2 state, that whether the DFA for this is complete or not. No, it is not complete. Only for 0 we have output. We don't have output for 1. So what we should do, we should just check out what will happen if I have 1, 1 at the back. From Q0 to Q1, I have 1. From Q1 to Q2, I have 1. Now I want to know if I get 1 at this point, where should I move? Since having 1 at this point won't make any difference, so I can comfortably loop around in this particular state for input 1. And the last one which I want is for Q3 state. Corresponding to Q3 state, I don't have any output for 0 or for 1. If I have 0, that means I should move back to the original Q0 state. And if I have 1, I should consider this one as first input of 110, 1, 1, 0, output should be 1. So with this, we complete the Mealy and Murray machine construction for very basic things. Now this is the final output which we get corresponding to 110. Now we move towards conversion. Conversion first is conversion of Murray to Mealy. Conversion of Murray to Mealy is a very easy job. This will not require much of the efforts. Just see this. We just need to check. Say for example, on the left hand I have a Murray machine. Corresponding to every input, we will check what is the in move on that particular state. Now on state Q0, just see there are two in moves. One is Q1 to Q0 on 1. Another is Q2 to Q0 on 1. What we will do, we will just convert this. We will take this symbol out and put it on the in move. Then we have one in move over here. We will just move this over here. Next we go to Q1 state. In Q1 state we have 1. There are 2 in moves corresponding to Q1 state. We will identify those 2 in moves, and what we will do, we will just take away 1 from Q1 state and we will put this one on in moves. So first 1, 1, second is 0, 1. Now we move to Q2 state. In Q2 state we have 2 in moves. One is from Q0, another is from Q1. Corresponding to Q1 we have a 0, corresponding to Q0 we have 1. What is there in the state? 1. So what we will do, we will just put a 0 followed by a 1 as output in the in move of Q1, and likewise we will put 0 oblique 1 in move of Q0 to Q2. So this is the final output. So this is how we have converted a Murray machine into a Mealy machine. There is another second example of Murray to Mealy. Again, very simple example, very simple to do. with 4 states. Initially, we start with Q0 state. In Q0 state, we have only single move, that is Q2 to Q0 on 1. What we will do, we will just convert this move. We will take away 0 from Q0 and put it on the 1 of Q2 to Q0. Then we move to Q1 state. We have 3 in moves. One is from Q0 to Q1. Another is from Q0 loop on 0, and third is Q3 to Q1 on 0. What we will do, we will just take away 0 from Q1 and we will put this 0 on all the in moves of Q1. Q0 is over, Q1 is over. Now we move to Q2. Just see here, we have covered Q0 with this is in Mealy. We have covered Q1, this is in Mealy. Now we move to Q2. In Q2, we have 3 states which are coming in from all 3 states, that is from Q0, Q1 and Q3. And Q2 has a symbol of 1. So what we will do, we will just put a 1 around all 3 in moves of Q2 and we will take away the symbol 1 from the state Q2. Just see this. This is the transition which is taking place. Now we have 3 states which have been converted into Mealy. We move to the 4th state, that is Q3. Likewise, the operation will be performed. We have only 1 in move and we have converted. So this is the final output for Murray to Mealy. This is very simple, no special effort required. Now we move to Mealy to Murray. We have covered Murray to Mealy. Whenever we talk about Mealy to Murray, first point which we should draw is that we should draw a table and check whether output on transition from input moves are same or different. In Q0, we have only 1 move, that is from Q1, and the transition is on 0. In Q1, we have 3 moves, 1, 2 and 3. Corresponding to all 3 moves, output is 1, 1, 1. In Q2, we have 2 moves, one from Q3, another from Q1, and corresponding to both the moves, the output is 0. As far as Q3 is concerned, it has 2 moves, one from Q2, one from Q1, and both moves have output as 0. Since there is no collision of outputs at any state, we can comfortably draw this machine without going in for any split of states. So if we talk about this, we will just start with Q0. Whatever output we have corresponding to this input, we will put in the from transition to state. Just see this. This is the output of Q0 which has been put now Q0 / 0 and it has been removed from this state. Likewise, Q1, 3 in moves, all with 1. Move the 1 of all 3 states to Q1 and remove transition output from all 3 states. Next we go to Q2 state. Same, 2 in moves, one from Q1, another from Q3. Both have output 0. So what we will do, we will just shift these 2 zeros to Q2 and these symbols will be converted into Murray. And same is for Q3, 2 inputs. We will add both these inputs to Q3 / 0. Fine. Now we have converted this particular machine into a Mealy machine. Mealy machine into a Murray machine. Next we go to a question in which we are considering minor changes. Just see this. What is happening as far as Q0 is concerned, when we draw the table, there is only 1 in move for 0. In Q1, we have 3 in moves and here 2 in moves are from 1 as output and 1 in move has 0 as output. Just see in the table also, I have marked it and highlighted it that we have 2 out moves, one is from 0 and another is from 1. If we have such situation, then that particular state, which is Q1 in this case, will be split since there is only one state having different output to a state. Now, what we will do, these are the 3 states, 2 have 1, 1 has 0. Now, in such case, what we will do, initially, we will concentrate only on states which don't require split. Q0 does not require any split. So this is okay. We will comfortably convert this into Murray by putting this output on Q2 as 0. Then Q1 requires split. We will wait till the end. Q2 does not require any split. So we will convert this. We will take into consideration both the inputs. Output was 0, has been converted into Murray. Now we consider Q3 since no split was required. In this case, we will consider both the in moves to Q3. One is from Q0, another is from Q2. And we will again convert it. Now the point arises, what about Q1 state, which had different outputs corresponding to 3 inputs? We will split this state Q1 into 2 parts. One is Q11/0, another is Q12/1. Same state name, different superscripts and outputs. Now next step, after we split this into 2 parts, is we will take into consideration what was the out move on the initial Q1 state. In the initial Q1 state, there were 2 out moves. One was Q1 to Q0 0, another was Q1 to Q2 1. What we will do, we will take into consideration these 2 moves and likewise we will give same 2 moves on both states. So now instead of 2 moves which we had earlier, we will have 4 moves now. Initially it was Q1 to Q0 on 0. Now it is Q11 and Q12 both on 0 will go to Q0. Likewise, there was only one move in Q1 corresponding to 1. Now there will be 2 moves, both out moves from both these states, Q11 and Q21. So first step is split. Second step is make the out moves from both the states. So just see this. This is what we have done. We have ultimately generated 4 outputs instead of 2 outputs. Next step is we need to consider all the in moves which were coming to Q1 initially. All the in moves which were coming with output 1 will move towards output 1 of the split. All the in moves which were coming with output 0 will move towards the state output 0. So this is how we will split and generate a Murray machine corresponding to a Mealy machine if there were more than 1 outputs. Just see this. Corresponding to 1, we are moving here. There was move on 0, which we are moving here. So this is the final output. Once we get the output, we should always check that the DFA is complete by drawing this particular table. So initially we had these states. Now we have one more state and there are 2 parts of the state, Q11, Q12. And since we have all states having outputs corresponding to 0 and 1, we can say that this is a complete DFA. Now we move to third question in which we have 2 states instead of 1 which will be split. Now just see this, 1, 0, 1 for Q1 1, 0 for Q3. Just see the table I have highlighted. 0, 1, 0, 1. So that means two states will be split in this case. Initially, we will start with all those states which will not split. So Q naught, no split. We will cover up that. We will convert this into Murray as in the similar steps as we considered earlier. Q1 needs a split. We will not consider it. We will move towards Q2. Q2 does not require any split. We have two in moves. Both have 0 as output. We will just convert this particular Mealy to Murray by putting the output 0 in state Q2 and taking into consideration both in moves with a single transition. Now we have to split Q1 as well as Q3. Initially we will start with Q1. Again we will split it into two parts. Process remains the same. First step is split them. Second step is once you have split them, take into consideration the outputs which were generated from the initial states. Initial Q1 had one output on 0 to Q0 and output of 1 to Q2. Now these two outputs will be 4 outputs because they will be from Q1 1 as well as from Q1 2. So instead of two outputs, now we will have 4 outputs. 2 from Q1 1, 2 from Q1 2. Next move will be, we will take into consideration their in moves. Out moves have already been considered. There are 3 in moves. 2 in moves have output 1. 1 in move has output 0. In move which has output 0 will go towards 0. In move which has output 1 will go towards the state 1. So this is how it will happen. Just see this. Now we are converting this into Murray. Output 0 moves towards 0. The inputs which had output 1 will move towards. So we have completed Q1 split. Now we will move towards second state which requires split. Again 3 steps. First step, split the state into 2 parts, that is Q31 and Q32. Next step, take into consideration the outputs of the initial state, that is Q3. There are 2 outputs, one is to Q2, another is to Q1. These 2 outputs will now become 4 outputs, one from Q3 1 and another from Q3 2. Same steps which were followed earlier. Here Q3 1 had Q1 2. Now Q3 1 as well as Q3 2 will move towards Q1 2. Likewise, Q3 1 initial state had only one output 0 to Q2. Now both states will have output to Q2. Outputs have been covered. Next step is inputs. When we talk about inputs, we just need to take into consideration all states which had input 0 will move towards 0 and all states which had input 1 will move towards 1. And the machine will be converted from Mealy to Murray. Just see this. This had 1 as output, so this will move towards here. This had 0 as output, so it will move towards this. So this is how we have converted a Mealy machine into a Murray machine where we had 2 states which required a split. This is the final output which we get. We need to verify whether this is a complete DFA or not. We are verifying it with the help of this table. This table says that we have a complete DFA. So the final output is this. This is how we have converted a Mealy machine to a Murray machine. Now this is the last question in which we have two inputs or two states only, and both states have different outputs. Just see in the table, out transition 0 and 1, out transition 0 and 1. That means both states need to be split. So what will be the first step? First step will be split this Q1 into two parts, Q11 and Q12. Consider both the out moves. Second step is consider the out moves. Initially we had only two, now we will have four. This is how things will move around. Similar to what we have covered in the earlier questions. Just see this. This is converted into Mealy, Mealy to Murray. These two inputs. Now at this point we had this 1/0. That means this move will go towards output 0. So we have added this move over here and output from these two moves. Earlier it was only from this move. Now it will be from both moves, which will go to Q0. Next we have split Q0, Q01, Q02, one with output 0, another with output 1. And consider the out moves of both. In one, the output was for Q1, which will be for both now from Q01 as well as from Q02. Second output was a self loop. It will be, since it was for 1, it will be a self loop for 1, and from 0, it will be a move towards 1. So instead of 2 out moves, now we have 4 out moves. So this is how things will move around, and we will convert this machine from a Mealy machine to a Murray machine. Fine. We will check the entire machine through a table that it is a complete DFA, because it is a condition for Mealy and Murray machine that the DFA should be complete. We will check this. We find yes, that DFA is complete. So this is the final output.